Hello everyone, I am Sri Devi, Professor, Department of Electronics and Communication Engineering. In this video lecture, we are going to learn about random process and random variables. On completion of this module, the learners can be able to understand the concepts of random process and random variables. First, we have to know the definition of random variables. So, a function which takes on any value from the sample space and its range is some set of real numbers is called as random variable of the experiment. Simply, a random variable, it is usually written as x, and it is a variable whose possible values are numerical outcomes of a random phenomena. Random variable consists of two types. They are discrete and continuous random variable. Discrete random variable and continuous time random variable. This type variables defines discrete or continuous type random processes. So depending upon the random variables, the processes are also defined as discrete random process and continuous time random process. For a random variable, the outcome of a random experiment is mapped to it onto its variable. For example, a number should map its another number. That is, a random variable is not random since it takes the values from the well-defined sample space. So, it is not variable since it has fixed value when it occurs. So, sample space, a set of possible outcomes of an experiment is called as sample space, and a function which takes on any value from the sample space in its range, that is some set of real numbers, is called as random variable of an experiment. So as said earlier, the random variables are classified into continuous time and discrete time random variables. So a discrete, let us talk about discrete time random variable. A discrete time random variable, so it is a variable in it's one which may take on only one countable number of distinct values. So simply the definition can be defined as a random variable x is a discrete random variable if the condition is satisfied. That is, if x can take on only one finite number of values in any finite observation interval. Thus, a discrete random variable has countable number of distinct points, that is x in between the sample space 1, 2, 3, etc. up to some countable values. So continuous next is the continuous random variable. That is, there are many physical systems that generate continuous time outputs, that is called as continuous random variable. So after getting the knowledge of a discrete time and continuous time random variable, we have to know the probability distribution function. So probability distribution function of a discrete time random variable is a list of probabilities associated with each of its possible values. So probability PDF is the definition, that is probability derivative of cumulative distributive function with respect to some dummy variable is called as probability density or probability distributive function. So PDF can be classified for discrete time random variable, and for continuous time random variable can also be written as, for discrete it is P of x is equal to xi equal to pi, and for continuous time random variable fx of x is equal to d by dx of f of x. So properties of distribution function. So first property is a random variable in between a and b. It can be defined as P of a less than x less than or equal to b is equal to f of p minus f of a, where f of x is equal to p of x less than or equal to x. Property 2 states that when random variable x in between a and b, P of a in between x less than or equal to b is equal to p of x is equal to a plus f of b minus f of a. Then property 3 states that x in between a and b, P of a less than x less than or equal to b minus p of x is equal to b, that is equal to f of b minus f of a minus p of x is equal to b. These are the properties of probability distribution function. Then continuous time random variable, it is an variable which takes all possible values in the given interval and also it produces a continuous output that is called as continuous time random variable. We can tell the example as age, height, weight, or continuous time random variables. So we have to know about the random process. We already know about what is random variable. Now random process. Random variable is already we know that random variable is the function of the possible outcomes of the experiment, but it does not include the concept of time. So in case of random process, we have to include or we have to consider the time. So in real time situations, we come across so many time varying functions which are random in nature. So definition of random process can be stated as a random process, or otherwise it is called as stochastic process. It's an ensemble or sample space. Such sample space consists of sample points whose outcome is a random function of time. We can differentiate random variable and random process like this. That is, random variable is a set of numbers and random process is a waveform. And random variable is need not be a function of time, but compulsory random process is a function of time. And random variables are not further classified, but random process is classified as stationary random process or ergodic random process. Finally, and random variable are only ensemble averages can be calculated, but in random process ensemble averages and also time averages both are calculated. So this is the concept of random variable and random process. So we have the difference between random variable and random process. Simply it is random process can be classified as random variable, and if time t is included, it is again further classified as discrete time and continuous time random variable. If time is included, it is also again classified as discrete time and continuous time random variables, and continuous time random variable produces the output as continuous form. So we have the quiz question based upon random process, that is, which method is better and efficient? Vector quantization, scalar quantization, vector and scalar quantization, and none of the above. So we have to know that the vector quantization is always better, that is, it is equal or exceed the performance of scalar quantization. So always vector quantization is better. So hope you all understood this session. Thank you for watching.